Hello guys, today we're going to finish 2.2 more on functions and their graphs. So we're going to study piecewise functions. A function that is defined by two or more equations over a specified domain is called a piecewise function. Okay, you can pause this video and read this example and see when we're going to use piecewise functions. But this lesson we're going to focus on how to solve the piecewise functions, or you can say how to evaluate a piecewise function. We're going to look at the example 3. So example 3, evaluating a piecewise function. So here we have a c of t. Probably you're more used to f of x. It's the same thing. Right here they're just use c as cost and t as time. Okay. So anyway, when they're talking about the evaluating, okay, in the past I mentioned many times, anytime you see evaluating, that means you're going to plug in. Okay, for part A, we have a c of 30. Okay, we're going to evaluate this. So in this case, we're going to see 30 is satisfied with the first domain condition or the second. If you look at the t, all right, so that is 30. So in this case, t is 30. That will be satisfied this, the first case, correct? Because 30 is between 0 and 60. So then in that case, we're just going to plug in 30 for the first equation. Okay? So in this case, there's no t, there's no variable, which means this is just going to be a constant. No matter what t is going to be between 0 and 60, your output is 20. So we use the first equation, all right? So for our part B, we need to find the c of 100, okay? Now we're going to look which equation work for us. So since 100 is greater than 60, okay, that means we have to use this second equation. Okay, so we're going to plug in this 100 for a second equation. That will be 20 plus 0.40 times t is 100 minus 60. Again, because 100 is greater than 60, that's why we're using this. Okay, so then we're going to evaluate this. So there's a whole thing I'll give you 36. That's how you're evaluating a piecewise function. Let's try another one. Here we have f of x equal to 6x minus 1 if x is less than 0, f of x equal to 7x plus 3 if we have x greater than or equal than 0. Okay, we want you to evaluate f of negative 3. So first you need to look, negative 3 is going to be satisfied the first equation or second equation. Since negative 3 is less than 0, we have to use our equation 1. Okay? So that means we're going to plug in negative 3 for the equation 1. That will be 6 times negative 3 minus 1. So which gave us negative 19. Okay? And then let's try another one. If we need to evaluate f of 0, so we're going to see which one that will be satisfy our condition. In this case, x is 0. That means we have to use the second equation, right? So that means I have to plug in 0 to 7 times 0 plus 3, which gives us 3. In part C, let's evaluate f of 4. So look again, f of 4, that is greater than 0, so that means we have to use the second equation. That will be 7 times 4 plus 3 is 28 plus 3 gave you 31. Hopefully that helps you. So I'm going to label this, we use the equation 2, this one we use the equation 1. Alright, let's move on. Example 4, we have to graphing a piecewise function. So first, for this type of question, first you need to graph these two equations separately. Okay, so you have learned graphing something like this. F of x equal to x plus 2. You know how to graph this, right? So you can make a chart. We've done this before, so we can make a chart x, okay, and then you have f of x equal to x plus 2, right? So you plug in some points. I can plug in -2 or -1, 0, 1, 2, okay, if you want to plug in that much points. But since this is a line, you know you can plug in just 2 points, that will be form a line, so you didn't have to do this many points. Alright, so I'm just going to plug in, that will be give you this going to be 0, this going to be 1, 2, 3. Alright, I'm just plugging in 2 plus 2 equals 4. So I have an ordered pair now. So I'm going to plug it in really quick. So I plug in the points. Now I'm going to draw a line. So for the second equation, f of x equal to 4, that's just a horizontal line, right? That's just the same thing as y equals 4. So all you have to do is just draw a line right here. So it's a horizontal line. You didn't have to plug in any points in this case. You just memorize this. Y equals a number, just give you a horizontal line. So that is how you graph it without learning anything about piecewise function. So now let's go back and look at the domain. So for the first equation, f of x equal to x plus 2. So we say only when x less equal than 1, that will be satisfied the first equation. So which means when we look at this line, the only part works is less than equal than 1. Okay, so here is my 1. The only part works. Let me go ahead and highlight it. That means it's this portion. Okay, so less equal than, okay, this side. So since it's less equal than 1, so we're going to make this point a solid point. Okay, that is a solid point. Okay, and then we look at the second condition for when f of x equals to 4. So we're going to have x must be greater than 1. So in this case, again, my 1 is right here. Okay, so I'm going to graph this portion. The only part works for us is when it's greater than 1. Okay, this portion. So because it's greater, so we're going to have a open circle in this case. So that will be a open circle. Okay, then we're going to complete this line. Okay, I'm going to draw this line as well. Okay, obviously it's not perfect. So that is our final answer. Okay, if you want to erase the rest, that's fine, but for me, that will be good enough. Okay, so you draw the graph without thinking about domain. So then you just look at the domain, then give rid of the part that doesn't satisfy your equation. Okay, that's how you graph this. So your final answer, that will be something look like this. Okay, solid line, and then you're gonna have an open circle. That'll be your final solution. Let's go ahead and work on the next example. So here we have a definition of the difference quotient of a function. If some of you guys ever going to get into calculus class, you're going to use this a lot. Alright, example 5, evaluating and simplifying a difference quotient. So we have f of x equal to 2x squared minus x plus 3. Find and simplify each expression. Let's look at part A. So we need to find the f of x plus h. Alright, in the past we have learned anytime you have something inside the parenthesis, when you do this type of question, all you have to do is just plug this whole thing for your every x you see. So let's do this. So that means we're going to have a 2 times x plus h squared minus x plus h plus 3. Any x you see, you replace with your x plus h. That's what we did. Once we do this, we're going to simplify it. So we're going to have 2 times. You can use a FOIL method to simplify this, okay? Whatever method you like. So I'm just going to use the a plus b squared form. That will be a squared plus 2ab plus b squared. Okay, so here we had x plus h. So I can just treat this a is your x. That will be x squared plus 2 times xh plus h squared. Again, you can use the FOIL method to do this. So I'm going to write it down. That will be x squared plus 2xh plus h squared minus x. I'm taking this parenthesis off. That will be minus h plus 3. Once we have this, I'm going to do a distribution. Okay, once we have this, we're going to check if we can simplify further. I don't have any like terms, so that is my solution for my part A. Now we're going to work on part B. Part B, we need to find f of x plus h minus f of x over h. Alright, where our h cannot be 0, because that's the denominator, cannot be 0. Okay, how can I do this? If you look right here, f of x plus h, we just found that, correct? We just found this right there. So that is my f of x plus h, because we just found this. I can just substitute the whole thing at the first portion right here. Okay, all I did is just a substitution, because that I already found this piece. So then from there, I'm going to look, what is, I have to subtract f of x. What is my f of x? Okay, I have to subtract, maybe I'll just put a parenthesis here. So I have to subtract f of x. I'm going to look at what is my f of x. That is my f of x, right? So now I'm just going to substitute this blue part in here. So that will be, again, this is a subtract. You really need this parenthesis, okay? Otherwise, you can get the whole thing wrong. It's the whole thing over h, okay? Again, you need to look. I just find this f of x plus h, subtract f of x is just the blue highlight part, and then I subtract. When I subtract, you really have to really be careful on this. Maybe I'll just highlight this part for you. You need this parenthesis, okay? Otherwise, you'll get this whole thing wrong. Once we do this, the rest of the stuff will just simplify, okay? So I'm just going to copy it down. And then what I'm going to do is I'm going to take the parenthesis off. Okay, that will be subtracted 2x squared. Negative, negative become positive. That will be plus x. And then here, negative. This is positive. That will take it out from the parenthesis, give you minus 3. This whole thing against over h. Okay, so once we do this, now we're going to look. Okay, we have a 2x squared, we have subtract 2x squared. So they are going to be gone, right? Then we look, we have 2xh. I can't simplify this, all right? There's no like term, so I'm leave it alone. And then we also have 2h squared. I'm going to leave it alone. Then I look at this, we have a negative x. We also have a plus x. So they're going to be gone as well, okay? And then we also have a plus 3. We have minus 3. So they're going to be gone as well. And then what left over, that will be 4xh plus 2h squared, and then minus h over h. Once we have this, we can continue simplify. We can take this. We have h, and h. We're going to take h out. Then we're going to have a 4x plus, you take a 1h out, that will be 2, still have a h left, and then minus 1. And then the whole thing over h. Now you look, we have h and the h, they are going to be canceled out. Okay, then our final answer, that will be equal to 4x plus 2h minus 1. So that is your answer. For this type of question, if you did it correctly, okay, in the end you should have something really nice. You shouldn't have a fraction. That is how you solve this type of question. So you can try some homework, and if you still struggle on this type of question, and then you should come to me and then ask questions. Thank you for watching the video. I'll see you guys next time.